Hello everyone. Today we're taking a look at the 3-1 notes, parallel lines, and transversals. Our objectives today: identify relationships between two planes or two lines, and we'll also name angle pairs made by parallel lines and transversals. Okay, so taking a look here, our first definition is parallel lines. Okay. Parallel lines are coplanar lines that never intersect. So we can have an example. Parallel lines here. These two lines, M and N, are parallel. The symbol that we can use one of these filled in arrows, going the same direction here. That's the symbol we use to say that those two lines are parallel. And if we were going to write it in symbols, we could say that M is parallel to N. That's how we would write it symbolically. Okay. Next definition are skew lines. Skew lines. Skew lines are lines that do not intersect and are not coplanar. So you can imagine having two separate planes here, and one line is, let's call this one line L, and the line K. All right, those lines, they will not intersect because they are not coplanar. All right, so there's no real symbols for skew. We just say that line L is skew to line K, or vice versa. Right. Lastly, we have the definition of parallel planes. Are planes that never intersect. So parallel planes, you can think of the ceiling and the floor. If you thought of those as planes, it would be parallel. They do not intersect, no points in common. And so if you're going to try to draw a representation here, again using that parallelogram type shape for your planes, okay, you can imagine that these planes, like the ceiling and the floor, are parallel. Let's name our planes P and Q. All right, and so symbolically, very similar to the parallel lines, except we use plane P parallel to plane. This was Q. Right. And so this example 1 is just having you identify each of the following using the cube shown. So all segments skew to BC. So let's identify here. BC would be this line. And we want segments that are skewed to it. So segments that are not coplanar but do not intersect. So one that comes to mind here, HE, just looking at that. Those are not coplanar. They also don't intersect. So EH would be a segment. EH, then opposite of that, we have this segment FG, so the line through EH, segment FG. And just think here for a second on your own, there are two more that you could identify that would be not coplanar and then non-intersecting. I think if you look at this front face, this segment here, AF and BC, they're not coplanar. They don't intersect, and then as well, DE, opposite AF, they're DE as well. So those are the segments that are skew to BC. Any other segments would certainly intersect BC or would be coplanar with BC. All right, so I'll erase my lines here so that we can identify the next couple of cases here. So here we want segments that are parallel to EH, parallel to EH. So here's our line EH. So it's on that bottom face of this box. Well, certainly the segment opposite to it, that segment FG. Those are coplanar. They're both on the bottom, so FG is parallel to EH. If you kind of think of EH being on that side of the box, you can certainly see that DC is parallel. Then it kind of becomes a little more difficult to visualize this last one, so let me clean up those couple of lines that we had. Actually, we can say that AB is parallel as well. The segment AB would be parallel to EH, and you just need to imagine if you cut this box from corner to corner, you could see there would be a plane there that connects those two. So those two lines are coplanar, so they would be called parallel. Okay. All planes parallel to DCH. So our last example here, we need planes that are parallel to DCH. Of course, it's going to be useful to us to identify plane DCH. So we're talking about this side of the box here. Okay. So the plane that would be parallel to DCH, of course, would be the side of the box that is opposite ABG, AFG, ABF, okay, just that side that's opposite it there. Plane, let's go with ABG, how we named it first, ABG. Of course, when naming a plane, you can use any three non-collinear points on that plane to name it. So that's example one. Now we're going to talk, well, first we're going to define a line that intersects two or more coplanar lines. So a line that intersects two or more coplanar lines is a transversal. Okay, and so let's draw two coplanar lines here. Let's kind of back to our first example here. We had line M and N. They don't necessarily need to be parallel. And then a transversal would be a line that intersects M and N. So line T, in this case, is a transversal of M and N. And there's no real symbol for transversal. We just say that T is a transversal of lines M and N. All right, and as you can see here, there's quite a few angles that can be formed when we have a transversal intersecting two or more lines here. So if we look here at this example, let's use M, N, and T. Of course, this is much better than my hand-drawn version of this. If we look at this example over here on the side, we can, let's number all of the angles for them. Let's count how many angles there are here. So here at M and T's intersection, there would be 1, 2, 3, there'd be 4 angles created there. And then again, when T intersects N, there's 4 more. So it's what total? We got 5, 6, 7, 8 angles created here. All right, and really for this lesson and the next as well, we're going to talk about some specific angles and angle relationships that can kind of exist when we have transversals. All right, so let's get into that. Exterior angles. So exterior angles are angles that are outside of your two lines M and N. So examples of some exterior angles here, angle 1 and 2, they're above M, and 7 and 8 are angles that are below N. So they're kind of opposite each other. They're exterior. They're outside of our two lines. So we said angle 1 angle 2, angle 7, and angle 8, angle 8 are all exterior angles. So then my interior angles would be the angles that are inside or in between my two lines. So 3, 4, 5, and 6 are interior angles. They're between M and N. So angle 3, angle 4, angle 5, and angle 6 are what we call interior angles. They're inside of M and N. All right. Consecutive interior angles or same side interior angles, these are pairs. The rest of these are going to be pairs of angles that we discuss. So for same side interior, alternate interior, all of these are going to be pairs of angles. And the first pair we're going to talk about are same side interior angles or consecutive interior angles. And this just means that they are on the same side of T, the transversal. So interior angles that are on the same side of the transversal, I'll use my green now, 3 and 5 are both on the left side of my transversal, and they're both interior angles. So those would be same side interior angles. Angle 3 and angle 5 are a pair of same side interior angles, or we sometimes call them consecutive interior angles, meaning the same thing. So then on the right side of my transversal, I also have a pair. The pair that would be on the right side would be angles 4 and 6. That would be a pair of same side interior angles. Alternate interior angles. Alternate interior angles are interior angles that are on the opposite side. They're on the opposite side of the transversal of T. So alternate interior angles, examples of those pairs would be angle 3 and 6. They're on the opposite side of the transversal. Angle 3 and angle 6 are a pair of alternate interior angles. My other pair of alternate interior angles, of course, then 4 and 5. That's a couple of examples there of alternate interior angles. All right. Taking that same idea of being on the opposite side of the transversal, well, let's apply this to, this time, our exterior angles. Okay. So my exterior angles that are on the opposite side of the transversal would be, we'll use blue, I guess, 1 and 8. Angle 1 and angle 8 are alternate exterior angles. The other pair, of course, then would leave it to be 2 and 7. Angle 2 and angle 7. All right, so those are my pairs of alternate exterior angles. And when we talk about corresponding angles, we are talking about, they are in the, I guess, how I kind of define corresponding angles. They're in the same position of the intersection. And so let's identify, there's going to be 4 pairs of corresponding angles here. So let's identify those. Start with green. So angle 1, if we're looking at the intersection of M and T, angle 1 is in the top left of that. If we look at the intersection of N and T, angle 5 is in the top left. So angle 1 and angle 5 are corresponding angles. Let's go to red. If I look at the top right of my intersection of M and T, that would correspond to the top right of my intersection of N and T. So angle 2 corresponds to angle 6. angle 3, the bottom left angle of M and T, corresponds to the bottom left angle 7 of N and T. So angle 3 and angle 7 are a corresponding pair. And my last corresponding pair, the bottom right there, angle 4, corresponds to the bottom right of the other intersection, angle 8. Angle 4 and angle 8 are corresponding angles. And so if we go to our next page here, refer to the figure, name the two lines and the transversal that form each pair of angles. Let's get through this example here. Identify each pair of angles as alternate interior, alternate exterior, corresponding, or same side interior angles. So this first example, 7 and 3, let's find 7 and 3. So 7, that's here where B intersects D, and 3 is where A intersects the transversal D. So the two lines, A and B, are intersected by transversal D. That kind of takes care of this first part of the question. And now we need to identify them as alternate interior, alternate exterior, corresponding, or same side interior angles. So again, we're looking at where B and A are intersected by the transversal D. And so when we really focus in on this part of the picture, the parts that I've highlighted here, we see that 3 would be an interior angle and 7 would be an exterior angle. So they're not both exterior, they're not both interior. So that kind of really does eliminate alternate interior, alternate exterior, or same side, because both of them aren't exterior, both of them aren't interior. So it eliminates those pairs. So really that leaves us with corresponding, which when we talk about corresponding, remember corresponding, that's the same position of the intersection. Well, 3, that's the bottom right of that intersection. 7 is the bottom right of that intersection. So these would be corresponding angles. They're corresponding angles. Okay. And similarly, guys, we're just going to continue this kind of pattern to identify the rest of the pairs. So I'll erase so I can highlight again. 8 and 2. Okay, well, 2's right here. 8 is right here. Again, maybe I shouldn't have erased. We're still talking about the transversal being D, and the two lines that are getting intersected here, A and B. So transversal there is D, A and B are the two lines. All right, well, 2 and 8, those are both exterior. They're outside of A and B. They are on opposite sides of the transversal. So these would be alternate exterior angles. Alternate, and I'll abbreviate so I leave myself some room. These are alternate exterior angles. Let's do one more together here. Okay. 4 and 11. So 4 is there, 11 is here. So the transversal here, again, the transversal is D. That's not going to change. The lines that we are talking about, though, A, and in this one, we're not using B, we are using C. So we can kind of ignore B being a part of this. So if we look at transversal D intersecting A and C here, again, they're not both interior, they're not both exterior, so that really eliminates those 3 alternate interior. It can't possibly be those. And again, 4 there is in the bottom left of its intersection. 11 is in the bottom left, so that would be a pair of corresponding angles. Okay? And so you guys go ahead with 7 7 and 1, 3 and 9, 7 and 10. Compare those kind of in the same way we've done. Okay, so pause, go ahead and do that. All right. So hopefully you've come up with 7 and 1 also being, those would be alternate exterior angles. Both exterior, they're on opposite sides of the transversal. 3 and 9, you would have compared again line A and C. 3 and 9 are both interior, opposite sides of the transversal. So these are alternate interior angles. 7 and 10, so you're kind of ignoring A, you're looking at lines B and C, and with transversal D. And 7 and 10, both interior, they're on the same side of the transversal. So these would be same side interior angles. All right. On your notes here, there is one more example. Really need to focus in this picture. Some of the times you'll be taking lines M and N and using the transversal being P. Other times the transversal might be different. So kind of focus in. Go ahead and give those a shot. And your homework is the skills practice worksheet that's likely been passed out. All right. Thanks for watching, and good luck to you all.